Hey there, everybody. Welcome back. My camera's not working, but I can share screen and capture what I want to do here. I have my document camera, so I could put my face on there upside down for a second, but y'all know what I look like. Today we're doing 9.5 in John Blakely's textbook. This is on piecewise functions. This is a video just so we can get caught up. So piecewise functions come in parts. Depending on where you are in the domain. One of the most famous ones is actually the definition of the absolute value function. And rather than telling you right away what it is, why don't we explore the graph of it and see what we gather from it? So this is our x-axis, our y-axis. On that side, it's like this. On this side, it's like that. So on this side, this is the blue line, looks like the line y equals x. But it's only going from 0 to infinity. It doesn't extend over to the left side of the graph because it would keep coming down like this. And the left side looks like y equals negative x. If you calculate the slope, we'd write this in a linear equation, slope-intercept form. We have y equals mx plus b, we get y equals negative x. But it's not extending into the positive region, so it's really only negative infinity to 0. So that's what we do for absolute value of x. For its piecewise definition, we say f of x, which is the absolute value of x, equals, and then we do something that does curly braces. First, we say what the f of x function is for this part, and then we say over what domain. So it equals negative x from negative infinity to 0, or it's usually not written in interval notation. It'll be x is less than 0. Thankfully, no one likes that interval notation. Well, no one that I know. And then on the positive side, it equals x, and that's x is greater than 0, and it actually has a value at 0, so we should put an equal sign on one of these. We can pick which one we want to do. Positive one seems like the friendliest one. We'll put that there. So that is the actual definition of the absolute value function. And this is really important in calculus. When working with limits, in calculus. So it'll come back up. Hopefully your teacher will remind you at the time. But having seen it before is only to your best interest. But we can see what I meant when we say it comes in different parts depending on where you are in the domain. In this portion of the domain, we have a line that is completely different than on the right side of the portion. Okay? And this is just a common one, but it doesn't have to simplify to something simple like this. Let's take a look at a more complicated one. Now, remember, you can always pause the camera or pause the video and take lecture notes. I'm going to try to make this shorter. That way you don't get stuck with a long video. we could have something like f of x equals x cubed if x is greater than 0. And x plus 3 if x is less than 0. So what does that look like? When graphing these, you have to pay attention to the inequality sign. And not just the direction, whether or not is there an equal part. Because less than and greater than are going to have hollow circles. Less than or equal to and greater than or equal to are going to have solid circles. So that changes how our graph looks. So what I'm going to do when I graph f of x that I have here, I'll throw down some axes. And since I have x plus 3, I know I have a line somewhere. For x greater than 0, it looks like x cubed, which 5, 6, 7, 8 comes up here and goes like that. Notice I didn't immediately start drawing the line. I drew the circle, hollow circle first, so I don't forget. And then I come over to the second half of the line, and it's x plus 3 if x is less than 0. If it helps you, you could draw both, but do it very light in like pencil. So that would be the x cubed. And then x plus 3 is going to go through 1, 2, 3, and it would go along this line like that. It would go like this. And since we are doing x is less than 0, we start our circle there, and we bring it down. And then we don't want that pencil confusing shit, so we're going to erase it. Okay. Second, I got sniffles, dust in here. Okay, so notice the lines don't connect. Connect. This doesn't always happen. But it can with piecewise functions. When it's like this and it doesn't connect, we call this a discontinuous function. And we say there's a discontinuity at wherever the line doesn't connect. X equals 0. Also notice x is not, or f of x is not defined at x equals 0. That just happens to be this case. Okay. So let's take a look at another one real quick. Actually, I'm going to bring this back, put it on another page real quick. No, we're going to do it on the next one. We're going to do another one. I want to do some evaluating with you guys, and we need to get that done. So let's take a look. We're going to make g of x miserable. It's going to have 3 parts. X plus 6 if x is less than -2. It's going to equal x squared if -2 is less than or equal to x, which is less than 1. And it's going to equal the negative absolute value of x if x is greater than 2. So it's got 3 parts. A piecewise function can have as many parts as it needs to if the graph is different over different sections of the domain. Okay. So let's take a look at graphing this. I don't know what I'm going to need, so I'm going to put some stuff in. Try to give some room on the graphing. Try to do it fairly accurate, not just sketch it lightly. And I'm going to go out 10 in each bar because I'm not sure what I'm going to need. All right. So the line x plus 6 goes through this and it has a slope of 1, which means -6 should be a 0. It doesn't look like I did this very well. And I want to do it lightly. And I want to do it with circles there. I don't know where it's going to be. I do know where it's going to be. I can look. I'm just sketching the line with a dashed line and pencil real quick. And then I can see it only applies when x is less than -2. -2 is right here on the graph. So I'm going to make it hollow. That should look hollow. Hollow. I think I put too many circles there to make it look like that. And then we're going to go like that. And so this should, I don't know that my line looks very good. This should be at the point -2, 4 meets that thing. And then for -2 to 1, we have a parabola. So it should be, it goes through that. 1, 1 would be a point, but we don't include 1. So I'm going to put a hollow circle on the 1. This is going to come down and make the parabola. And now I've got -2 is less than or equal to x. And it happens to be for this portion, 2, 4 is on that, or -2, 4 is also on that list. So I can fill this in with the green part from this portion here. Okay? Not from the top one. And then I have the absolute value of x negative if x is greater than 2. So the absolute value of negative absolute value of x, it goes like this. And we only want greater than 2. And we don't include the endpoint. So we've got 2, -2 down like that. And now I can go through and erase the penciled in stuff. Okay, so something worth noting. The x plus 6 equaled the x squared at x equals -2. So it's actually, even though it changes directions, it's continuous at x equals -2. And it not always is. Sometimes there's gaps. It doesn't make connections. And where this is discontinuous from, this function is discontinuous wherever we don't have a line. And that's between 1 and 2. It's this region right here. There's nothing there. So we'll say -1 less than, and the 1, not -1, +1. 1 less than or equal to x, less than or equal to 2. We don't have a point value at 1 or 2. It doesn't connect. Okay. Other things we can do with this function, we can do evaluating. So let's take a look at doing some evaluations. Let's do g of 0. I'm going to do g of 5. I'm going to do g of -5. And we'll look at g of 1. Okay, when I'm doing this to make these evaluations, this says what the x value equals. And that tells me which part of the piecewise function I got to use. For x equals 0, I am on the -2 is less than or equal to x less than 1, which means this is going to be in the x squared part. So I'll have 0 squared, and the value is 0. For x equals 5, I am now in the x is greater than 2 spot. So I'm doing the negative absolute value here. So I have the negative absolute value of 5, which is -5. This seems like a weird way. I don't know why I chose negative absolute value x, because this would just be -x normally. We wouldn't need the absolute value since we're only on x equals x greater than 2. But either way, we'll work with it. For the -5, we are on the x is less than -2 spot. So here we're in the x plus 6 range. I'm going to write down the values we had over here because I'm making a mess over on the left. G of 0, 0. G of 5 is -5. G of -5 would be -5 plus 6 is 1. So G of -5 equals 1. And I don't know if the document camera is getting in the way there. A little camera button might be screwing up. G of 1, we come up here and we look to see where 1 is in the domain. 1 isn't here. This gets close to 1, but it's not here either. It says x is less than 1. X is not less than or equal to 1. And then we have x is greater than 2. So x equals 1 is not in the function. G of 1 is undefined. So I'll write that down here with the rest. Now, we had already drawn the graph, so we can see all these values there. G of 0 is right there. That's G of 0. G of 5 is right here. G of -5, had I done a good graph, well, it's not bad. It's right there. And G of 1, nope, it's hollow. So no. So we can get the values from the graph, we've drawn it, but you should also be comfortable doing this without the graph. Plugging these in, going which section up here does it belong to, and then only doing that one. Okay. There is one more I'm going to show you. And then I'll give you a little practice. I'll pause the camera for you guys to do some practice, and then I'll show you. I mentioned this yesterday. It's called the greatest integer function. I don't know. It's got a terrible name. It's got a weird symbol, first off. We do double brackets like that. And what this function does is for any decimal value, it rounds down. So like f of 0 is just 0. F of 0.1, it rounds down to 0. F of 0.5 rounds down to 0. F of 0.9999 rounds down to 0. F of 1 is 1. So what this looks like on a graph if we wrote f of 0 right here, we have a value here, and it's perpetually 0 all the way over to 1, but then it's not 0 there, so it's hollow there. And at f of 1, it actually has a value, so it's there. And like so, f of 1.1 rounds down to 1, f of 1.9 rounds down to 1. This is going to go all the way up to 2, and as soon as it gets to 2, it jumps up to 2. So it makes this staircase. And the hollow point is one value or one unit below the left side of the line above it. So if we wanted to do some stuff with, like, let's say we had the function g of x was the absolute, or not absolute, the greatest integer function for x plus 1, g of 0.5 would be 0.5 plus 1. And in the brackets, we would have 1.5, and that rounds down to 1. And we actually kind of talked a little bit about how we move functions. This is inside it. You know what? Let's not do 1. Let's do 2. I think 2 is going to show better what's going on. I put 2. This is 2.5. And that would make this go to 2. So g of 0.5 would be 2. We're actually going to have this. And it's going to keep following that pattern. But following along with what we did yesterday with the whole f of x plus h shifts left to, we can see that happening. I'm going to darken this section right here so it shows up because it's not showing very well. This whole thing is moved left 2 units. This whole line is moved left, or line segment is moved left 2 units. The entire graph is moved left 2 units. It looks like it's moved up, but it hasn't. It's moved left. Okay. So let's see what you guys would do here. Let's, I'll have to walk you through the first one. We're going to rewrite the following. We're going to look at some absolute values that are a little more complicated. So remember, I'll put it back up here. Absolute value, when we have the absolute value of x, it equals x if x is greater than or equal to 0, and it equals negative x if x is less than 0. For some reason, that's the most common way we write this, whereas every other piecewise function, we put the most positive stuff on the bottom. And we just like writing absolute value like this. So we're going to rewrite, let's say f of x equals 3x plus 5. So we kind of want to say, well, we're definitely going to say it equals the positive version if we have 3x plus 5, and it equals the negative version if we have the negative version like that, which is the same as negative 3x minus 5. But where? If I try to use the same criteria as before, if I stick in like -1, -1 up here would be in the bottom one, right? And so it should, if I did f of -1, what value do I get? I get 3 times -1 plus 5, which is -3 plus 5, which is the absolute value of 2. So f of -1 equals 2. But that's this one. If I put -1 in there, I would have -3 times -1 minus 5 would be -3 or +3 minus 5, which would equal -2. So that's the wrong one. This clearly goes up here, but that's x is greater than 0. So that looks confusing because -1 here is not in x is greater than 0, but our answer is lining up with this. And the reason why is this shifts the center of the graph. Center of absolute value. So what we want to do is we want to set this equal to 0. So we have 3x plus 5 equals 0. And we solve. And we get x equals -5/3. That's our new center. Because this is the center. So we want center here as well. Our center has shifted over to -5/3. So this is if x is greater than or equal to -5/3. And this is if x is less than -5/3. A little tricky, right? So remember, absolute value of x is centered where this equals 0. We need to do that for this here and change our center. And when I mean center, I am talking about where that cusp is. So the center is at the cusp. Okay, pause that and figure that out. And then I'm going to put up 2 for you to do. So rewrite both of these as piecewise functions. We're going to do, was that f of x I did? Let's see. That was f of x. So we're going to say g of x equals the absolute value of 4x minus 8. And we're going to say h of x equals the absolute value of 4 minus 6x. Pause the video. I strongly recommend you pause the video that and try to do what we did on the last problem on these. And then once you've given it a try, come along and see what I can. All right, I'll assume you paused it. What I'm going to do is find the new center. So 4x minus 8 equals 0. Add 8 to both sides. I get 4x equals 8. Divide by 4, and I get x equals 2. So g of x is going to equal the positive version of this, 4x minus 8, if x is greater than 2, greater than or equal to 2. And it's going to equal the negative version of that, which is negative 4x plus 8, if x is less than 2. All right. We'll come over here. We'll do the same thing with this one. We're going to do 4 minus 6x. I'm going to use the inequality sign to represent the top one. So if I subtract 4 over, I get negative 6x is greater than or equal to negative 4. If I divide by negative 6, I get x is now less than or equal to 4/6, which is the same thing as 2/3. Okay. Actually, this isn't quite right. I don't need the greater than portion. That's not going to change. I realized this was nagging me, and I paused the recording of the video, and I did it over on paper, and I could see that this is just the equals part. So h of x is going to be positive version of that, 4 minus 6x, if x is greater than or equal to 2/3. And it's going to equal the negative version of that, which is going to be 6x minus 4, if x is less than 2/3. You'll see if you plot it. Four minus 6, I'll do it lightly in pencil. 4 minus 6x goes like this. Let me do that a little bit better. So that's the 4 minus 6x, 4 minus 6x right there. And if I do 6x minus 4, it starts at 4 and a rise 6, run 1. It goes like this. So our graph is that. And we can see if I do like x equals 1 or x equals 2, I should be on the 4 minus 6x part. So we don't need to worry about doing inequality signs when we're recalculating h of x or resetting the center, okay? If you want to pause it and try to graph this one over here, I encourage you to do so. Now we'll take a look at it together. Wait a second. I'm going the wrong way. This is negative, never negative. I showed that shit wrong. It's doing this. Wow, fail. Let's go with green right here. It's doing that part. So when x equals 2, it's not on the 4 minus 6. I was right. Son of a gun, I was right. So I'm going to go back in here and do that. So this should be less than or equal to 2/3, and this should be greater than 2/3. Okay? It's not down here. This is the 6x minus 4 part. This is the 4 minus 6x part. H of x is definitely positive because the absolute value, so it should be opening up. And if I plug in x equals 2, I need to be on the 6x minus 4 line. So that's the right inequality. Okay. If we do the same thing over here. Oh, wow. All the way up to an 8. 2, 4, 6, 8. 2, 4, 6, 8. 4, 6, 8. So these are in steps of 2. X equals 2 is the center of the graph. And it's going to do 4x minus 8, which is a rise of 4 over a run of 1, or a rise of 8 or over a run of 2. So we're going to have that. If we had done the inequality here like I was supposed to, nothing would have changed. And we still would have had x greater than or equal to 2. The only reason it changed is because we had a negative sign here. Okay? So this is the 4x minus 8 part, and this is the negative 4x plus 8 part. I clearly have this scaled wrong. All right, that should be x equals 2 right there. Yeah, we'll just say that's 1 and 8 is off the screen. That still works. Okay, so that's what you kind of have to do in the piecewise function sections. All right, peace.